Hello everyone and welcome back to the engineering projects. In today's video we are working on a very interesting electronic simulation project that is interfacing of the heartbeat sensor with the Arduino inside the Proteus. If you have ever wondered how heartbeat monitors detect pulses or how digital BPM counter works, then this tutorial is exactly for you. We'll cover the concept of the sensor, the Proteus circuit, the Arduino code, and finally the real-time output. But first of all, I would like to tell you what is a heartbeat sensor. A digital heartbeat sensor works by detecting the blood flow pulses in the fingertip. Every time your heart pumps blood, the sensor identifies a small change in light or the pressure generated, and then it generates the digital pulse. The digital output shifts between high to low. So when it is shifting from low to high, a heartbeat pulse is detected, and when it is shifting from high to low, the resting period between the pulse is detected. In Proteus, the sensor is simulated in a similar way. It continuously generates pulses to mimic a real human heartbeat. For this project, you will have to do some extra work. Why? Because the Proteus does not include the heartbeat sensor or the 20x4 LCD or the Arduino UNO. So for this project, you will need the following custom libraries. The first one is obviously the heartbeat sensor library for the Proteus. The second one is the new LCD library for the Proteus, and the third one is Arduino library for the Proteus. You just have to simply extract these libraries into the Proteus library folder and restart the software. After restarting, all the components will be available in the Proteus workspace. I'll provide the link of all of these in the description. So let's move to the circuit. I have created one for you. As you can see here, the circuit contains the three main components. The first one is obviously the sensor. The sensor has the following pins. The test pin. Here the user will provide if the hand is on the sensor or not. Fine. 0 means the hand is not on the sensor, so sensor will not detect anything, and vice versa is for the value 1. As you can see here, the output is connected with the DC voltmeter. This is for the better understanding of the output, and I'm expecting that the values on this meter will be fluctuating between 5 to 0 when the toggle value is 1, and the opposite is for the 0 value. As you can see here, the output is connected to the digital pin 7 of the microcontroller. Microcontroller will then read all the outputs continuously and will convert the values into user readable format. After that, it will display it on the LCD. So to control all these, you will need to have a code in the Arduino IDE, as I have this. To make the connection between these, we'll use a hex file, but before that I would like you to understand the code. Here is the ready code. If you are using the LCD for the very first time, you will have to include the library from this section. Once installed, you will be able to run this code. The code says that in the very beginning we have included the LCD library. This line will allow us to use all the features of the LCD. After that, I have mentioned all the pins of LCD that are connected to the respective pins of microcontroller. I have defined the pin 7. The void setup function in Arduino runs only once, so I have included the title of this project here. The loop function is continuously runs, so microcontroller will continuously read the output of Arduino output of the sensor and will convert the result into user readable format and will display it on the LCD. So to make the connection between the circuit and our code, we'll just have to verify the code. It will provide us the information of the hex file created in your system, and you just have to copy the hex file address of your system as I'm doing so, without any quotation marks. Let me show you how you will do this. See, now copy it, go to your simulation, double click on the microcontroller and paste it here, then click OK. If you are using the sensor for the very first time, you just have to provide the hex file address here too, but this time the hex file is of the sensor. You will click here and will provide the path of the library folder where you have pasted the hex file of your sensor, and click OK. Now our project is ready. Let's test it. As you can see, this is a title I have included in the setup function. At the moment the toggle value is 0. It means the sensor is not detecting anything. The sensor does not have our finger or any pressure, so at the moment it say there is no pulse. Now I'm creating the scenario that someone has placed the finger on the sensor. Fine. To do this, I'm going to just change the value to 1. So what is happening here, the system will detect that okay, yes, I'm getting the pulse, the values of this pulse are fluctuating from low to high and high to low as our heart pumps the blood. So the project is working fine, and I just want to explain the process of output fluctuation. As you have noticed that the value on the pin 7 keep flipping from high to low. This is not the noise or any error. This is the heartbeat sensor simulating blood flow pulses exactly like a real sensor. So every high pulse equal to 1 heartbeat. So I hope all the concepts are clear to you. Your project will work fine as mine. If you have any questions or you're stuck at any point, you can ask in the comment section. I hope this tutorial was helpful for you.